Today we will discuss about curl of a vector field. Earlier we have discussed about gradient of a scalar by applying del operator on a scalar field, and later we have read about divergence of a vector field by applying del operator on a vector by making dot product of del and a, and later we have studied about later we have studied about them, and now we will study about cross product between del operator and a vector. So what is the physical significance of it? These things we will learn today. Now I myself Ratan Kumar, assistant professor. Okay. So del cross A is represented by like this. Curl of A bar is represented by del cross A bar. Del cross A bar equal to, it is determinant of I bar, J bar, K bar and dou by dou x, dou by dou y and dou by dou z. And here we A vector components, these are all components of vector A. So let's look into the definition. The curl of a vector field is defined as a maximum line integral of the vector per unit area. It is essentially a vector quantity. So curl of A bar is a vector quantity. So when you multiply with a curl, you will get something is a vector quantity, whereas earlier gradient, earlier divergence, we have obtained a scalar quantity. Here we have obtained a vector quantity. So curl of a vector field is defined as a line integral of the vector per unit area. Suppose this is the area, we are choosing this yellow rectangle, so it has certain area A. The curl of a line integral, when we line integral of the vector per unit area, which we will discuss further. So in this diagram, let us consider that a vector field is derived as a gradient of the scalar field. Suppose we have a vector field, it is derived by using gradient of the scalar field. In this case, the line integral of the vector around any closed path in the field is 0. As we know, the line integral of a closed path of a vector is 0. Such a field is called non-curl field. So when it is 0, it is called non-curl field. However, there are vector fields for which line integral around any closed path is non-zero. So for curl fields, what will happen is line integral around a closed path is non-zero. So curl means some curve or some changes rather than uniform. Curl means there will be certain changes like that. So these fields cannot be derived as the gradient of a scalar field. Moreover, they show the property of the curl. Curl means some type of rotation like that. So the vector fields, now we will discuss about it. Now suppose I have consider two areas. Let's consider two areas A, B, C, D and A dash, B dash, C dash and D dash. Yeah, let's more we will written A, B, C, D and A dash, B dash, C dash and D dash. Like that way, a non-uniform. Suppose consider two areas A, B, C, D and A dash, B dash, C dash in a uniform electric field, which is represented by straight parallel lines as shown in the figure. As you can see, the area A dash, B dash, C dash, D dash is perpendicular to the lines of force. So, this dashed portion is perpendicular to the lines of force. So, that the contribution of line integrals is 0. For area ABCD, the line integrals along AD and BC are 0, while the line integrals along AD and BC are 0, while line integrals along AB and CD are not 0. This shows that there is a certain orientation of the area for which line integral is maximum. So, as you can see, along the direction there is a line integral and line integral perpendicular to the direction. As you know, line integral will get cos theta, here theta equal to 90 degrees, hence cos 0, cos 90 equal to 0. So, line integral along this direction only we will consider. So, finally, we have learned the curl of a vector field. So, the curl of a vector field is defined as the maximum line integral of a vector per unit area. It is a vector quantity. The direction is normal to area to the area. So, the curl is normal to the direction is normal to the area. The direction is normal to the area. That means what? It should be perpendicular to del cross and as it is a cross product. Suppose if we have a cross product A bar plus B bar, A bar cross B bar, sorry, A bar cross B bar, like this. Suppose there is A bar and B bar. So, the resultant vector is perpendicular to the plane of the A bar and B bar. So, it follows, the direction follows thumb rule. The curl of, suppose if a vector function is differentiable at each point xyz. So, earlier we have discussed about vector fields and scalar fields. Scalar fields, the region around the quantity will vary is a scalar quantity. Here the region around is the region is a variable is a vector quantity. So, here in vector field we will have a vector quantity. Suppose if A bar is a vector function differentiable at each point in a region of space, then the curl of A bar expressed by cross product of del cross del and A. As we know, earlier we have discussed about what is del. Del is nothing but del equal to, it is a vector quantity, dou by dou x I bar plus dou by dou y j bar plus dou by dou z k bar. So, please note down this formula del cross A bar and also this diagram. It is a determinant of del cross A bar is the determinant. Just like a bar cross vector product of A bar cross B bar, we represent del cross A bar. So, Ax, Ay, Az are components of A bar along x, y and z. Now, this is the expression of curl in Cartesian coordinates. We have represented this one in Cartesian coordinates. So, finally, we have derived. So, here we have to remember that the line integrals along AD and BC are 0. So, line integrals for perpendicular to the field direction are zeros, AD and BC are zeros, while the line integrals along AB and CD are not 0. This shows that there is a certain orientation of the area for which line integral is a maximum. So, there is certain orientation for which we will get a line integral maximum. So, we can find out that value by using curl. Let us derive this expression. Before deriving it, let us see about physical significance of the curl. General meaning of curl is rotation. So, when a curl A bar is 0, so when del cross A bar is 0, it means that no rotation is attached with vector A bar. So, no rotation is attached with vector A bar, whereas if curl A bar is non-zero, suppose if curl A bar is non-zero, it means that rotation is, there is some rotation with the vector attached with the vector A bar. To make it more clear, consider the flow of a liquid. Let a frictionless paddle be placed in the path of a liquid flow. Suppose suppose this is the direction, and now suppose in this direction in which it is going like this. Now, in this path I have kept one frictionless paddle in the path of liquid flow. In a hypothetical case, if we assume that all the liquid layers are moving with same velocity, so there is no viscosity here, where same velocity, the paddle will not rotate as shown in the diagram. This shows that the curl of velocity vector is 0 because the paddle is not moving, not rotating. So, the curl of a velocity vector is 0. If we consider that liquid layers are moving with different velocities, the liquid layers are moving different velocities, then the paddle will rotate. So, if each will move with different velocities, that means what? At certain place there is more force and below there is different velocities. Then what will happen? Then this paddle will rotate. So the rotation will happen in this direction depending upon that position. So the rotation is due to the non-zero value of the curl of velocity vector. Here we consider the following examples. When a rigid body is in motion, then the curl of its linear velocity at any point gives twice its angular velocity in magnitude and direction. So, when a rigid body is in motion, then the curl of its linear velocity at any point gives twice its angular velocity in magnitude and direction. So, here you will get curl V bar equal to angular twice the angular velocity 2W 2 omega. When a current is passed through a conductor, the magnetic field is developed around it. We know that movement of charges creates a magnetic field. At any nearby point, the curl of a magnetic field represents current per unit area passing through that point. So, in a magnetic field, the curl of the magnetic field represents current per unit area passing through that point. So, the curl B bar is also known as magnetomotive force. The curl, so the curl of a magnetic field represents current per unit area passing through that point. That means something like a current density, which we will get this curl on magnetic field in further coming chapters. There is a beautiful equations in Maxwell's law of electromagnetism. We will see those things in coming chapters. The curl of a electric field results that rate of change of magnetic field is in perpendicular direction. So, curl of a electric field and curl of a magnetic field results the rate of change of magnetic field in the perpendicular direction. So, the curl of electric field results that rate of change of magnetic field is in perpendicular direction. So, the curl of magnetic field results the flow of electricity. So, the curl of magnetic field results the flow of electricity. So, that is the physical significance of the curl. Now, let us derive this curl. Now, consider an infinitesimally rectangular area ABCD. So, consider this A, B, C, D, and in a vector field along xy plane. So, this is, let us consider x, and this is y, and as shown in the figure, let dx and dy be the sides of rectangular area parallel to x and y axis. So, this one is dx and this one is dy. Further, let the value of the vector field at the center P be a bar. And its components are ax and ay. Ax and ay along x and y axis respectively. Now, we shall consider the values of these components at the middle points. What is its values at suppose at this point, at this point. So, those points are called Q, R, S, T. Now, it should be remembered that rate of change of Ax along y axis can be given by dou Ax by dou y, and similarly rate of change of y along x axis is given by dou Ax by dou y, dou y, like that way, like dou Ay by dou x. Dou Ay by dou x. So, like that way we will have rate of change of Ax along y direction, rate of change of Ay along x direction. Now, increase in magnitude of Ax from going from middle point P to R is given by. So, here it is given by dou Ax by dou y equal to dou Ax by dou y into half of dy as it is in the middle. So, finally, we will get half dou Ax by dou y into dy. Now, this is the increase in magnitude of Ax in going from P to R. Now, similarly, we will calculate at other points R, S, T. So, at R what we will get is equal to Ax plus half dou Ax by dou y dy. At point T it is given by Ax minus half dou Ax by dou y dy. Now, Similarly, the value of ay at q is given by at q ay at q is given by ay plus of dou ay by dou x dx. Similarly, ay minus of dou ay by dou x into dx. Now, if we take the line integral of complete boundary, line integral along the boundary ABCD. If we take line integral along the boundary ABCD. So, here in this diagram, the line integral along the boundary, this boundary, if we take, so let's yeah. Now, if we components, if we multiply the components, so component of vector along AB plus BC into component of vector along BC plus CD into CD into component of vector along CD, component of along CD plus dA into so finally we have to multiply all these things. So we have to add all the components. So we have in this diagram what we have done is, suppose if we take AB, the component of vector not only length is dx into the component of vector along this direction, that is ax minus half into dou ay by dou y into dy. Similarly, this length and this length and this length. So we will add like this. So now let's consolidate this one, all these components. So if we consolidate, So this is the consolidated of all the components and line integral along this one. So the last two line integrals are taken as negative because components of the vectors are in opposite directions. So as the components are in opposite directions, we are negative, we are taking. Now if we consider this ay and this ay, cancel out this ax and this ax is cancel out, and minus of, so this ax by dy, this one will cancel out, and finally what we will get is dou. So finally we will get, if we add all positives and if we add all negatives, we will get dou ay by dou x minus dou ax by dou y into dx dy. Like that way we will get dx dy. So the line integral per so this one is area. So line integral per unit area gives, so we have to, because if we divide both will cancel out, per unit area. So like that way we have got this one per unit area. So this one represents magnitude of the curl E taken about z axis. So this one will represent about z axis. Now so this can be equal to curl component, z component of A bar. So what we got, yeah, now so this is the z component of curl A bar taken along z direction. So note it down, the steps involved in it. Now let us see the similar components. Now we have curl. So this is a k bar. Similarly, we have the components of curl a bar along y and x axis. So similarly, now let's consolidate all these components. So we have to plus plus plus. So finally we will get, if we place curly a bar equal to this component, this component and this component. We have to add all the components. Now let's add curl a bar is equal to, this one will come as I bar into dou a z by dou y minus so this is the final expression for the curl. So this one can be further expressed simplified way instead of this bigger one. Here what we have to observe, the I bar into dou z by dou y minus dou ay by dou z plus j bar into dou ax by dou z minus dou az by dou x. Here if we see, if j bar refers to the unit vector along the y direction, so in that case the components are doesn't contain y. So you can similarly k bar is along z direction, but the components doesn't contain z. As you can see, dou ay by dou x minus dou ax by dou y. So the components have shifted here like this. So here also the components y is at the denominator, numerator it changed, interchanged like that. So like this way all the three components have changed. So we can express this one more simply as, instead of writing all these things, we can write this one as like this. So if we expand this one, we will get this one. So final curl, the expression of curl is del cross A bar equal to determinant of I bar, J bar, K bar, dou by dou x, dou by dou y, dou by dou z, and ax, ay, az. So this is one of the important formula. This is about derivation of curl. So let's see different type of vector fields. This is about the curl and this is about the expressions. So now let us see different field having no divergence and no curl. Case 1, no divergence means del cross A equal to 0 and del cross no divergence, no curl. Such fields are called steady heat flow or electrostatic fields or gravitational fields, irrotational motion of incompressible ideal fluid. So that is called incompressible fluids. So these are called incompressible fluids because that is uniform, neither divergence nor curl. So if there is a curl like this or divergence, then it will be different case. Here nothing is there, so this is called incompressible. So you cannot compress the field. So incompressible fields. Field having divergence but no curl. So there are fields which have divergence but no curl. So there may be divergence but no curl. So in that case divergence not equal to 0 but curl equal to 0. The examples of such fields are gravitational fields inside a mass, electric field within a volume. So electric field within a volume, there will be divergence but there is no curl. So distribution of charge, uniform distribution of charge, and time independent Schrodinger equation, etc. Now let's take another case. Field having curl, that means del cross A not equal to 0 but divergence equal to 0. What does that mean? Magnetic field due to a steady current or incompressible fluid with a velocity. Now the field having curl and also divergence. So in that case, in this case what is happening? So here Maxwell's equations are the examples. Maxwell's equations within the matter. So like that way we will have different various types of conditions for getting the fields. Now we will have certain problems, physical significance. So curl of different expressions we can do the problems. So I want to thank Commissioner of Collegiate Education and Principal of Tara Government College Sangareddy. Thank you.